It's a little bit, I regard a bit like the Industrial Revolution, where, there was all these amazing new ideas about energy and power and so on. But it was fueled by the fact that there were dead dinosaurs in the ground, right? And coal and oil and just lying in the ground. Imagine how much harder Industrial Revolution would have been without that. We would have had to sort of jump to nuclear or solar somehow in one go. And I think that's what's happened with intelligence research and AI research, and the equivalent of that oil is just the internet. I think neuroscience has made a huge contribution to AI. It's sort of more subtle than just sort of pointing at, oh, which algorithm. I think it's just the soup of ideas, not only in deep learning, but also in reinforcement learning, which I think has been important. And other things too, even smaller ideas like memory replay, episodic memory, things like that. The seed of those ideas has come from our understanding of neuroscience, and even if they end up being implemented in a way that's quite different in silico. So I think we shouldn't underestimate that, and I think the neuroscience community should feel very proud of that. But we are moving into a new era now, I think, where it's now becoming very engineering heavy what we do at the cutting edge of AI, and the systems are increasingly sort of diverging from maybe what how the brain works. So I came to that realization maybe probably 4 or 5 years ago, as the sort of the scaling laws seem to start holding with these what have become now the frontier sort of large language models, and in fact they're not just language anymore but multimodal. Now, having said that, I still think there are missing things with the current systems. But if we were and we've had these discussions over many years, over the last decade, and if we were to be talking 5 years ago or something, I think I would have made arguments about how are these systems going to learn abstract concepts or form abstract conceptual knowledge, including eventually symbolic knowledge like language. Maybe we would be discussing about grounding in the real world through embodied intelligence or simulations. And it just turns out there is this other way to do it, but probably because it's a little bit, I regard a bit like the Industrial Revolution, where, there was all these amazing new ideas about energy and power and so on. But it was fueled by the fact that there were dead dinosaurs in the ground, right? And coal and oil and just lying in the ground. Imagine how much harder Industrial Revolution would have been without that. We would have had to sort of jump to nuclear or solar somehow in one go. And I think that's what's happened with intelligence research and AI research, and the equivalent of that oil is just the internet, this massive human curated artifact that we've been building over the last 20, 30 years, the whole of humanity's been building. And of course we can draw on that. And there's just a lot more information there, I think it turns out, than any of us can comprehend, really. And that's what these massively scaled AI systems are able to draw on. So I think that allows us to, along with some human feedback, by the way, the reinforcement learning human feedback, which I think some grounding seeps through that in effect, because we're obviously grounded agents. We're interacting with these AI systems. Perhaps they're ungrounded, but then they get grounded feedback, right? So effectively, there's some grounding, I think, seeping into their knowledge and their behavior through that approach. Now, so there's still things I think that are missing. I think we're not good at planning. We need to fix factuality. I also think there's room for like memory and episodic memory. So I think there's still a lot of room for inspiration to come from perhaps neuroscience ideas, but perhaps the peak of that has passed now. On the other hand, what I do think we should be taking from neuroscience is analysis techniques. So I think that's what I would, and I've talked to Tommy about this. This is what I'd pitch CBMM on, is that we're really lacking in our understanding of these systems. It's incredibly hard to do because AI is an engineering science. You have to build the artifact first, which is already very hard, before you can then decompose it scientifically and understand it. And that's a moving target, obviously. So it's a very empirical science, and I think we need an empirical approach as well as theory, but largely empirical approach to trying to understand what these systems are doing. And I think that neuroscience techniques and neuroscientists can bring to bear their analysis skills to this. So the kind of work I have in mind is things like Chris Oler, work at Anthropic. I think some of the best examples of this, of analyzing what these systems are doing and the representations and the architectures and so on. But I think we need like 100x more research on that. So that's got to be the goal. I think the other thing that the places like CBMM can do is the leading labs, I think, and including ours, would be willing to give early access and access to these very large models for the purpose of analysis and red teaming. And I think critically, we also need benchmarks to benchmark capabilities. So, and that obviously has safety implications as well as performance implications. So, for example, it would be good to know if these systems are capable of deception, but what does that mean? How can we operationalize that in a way that can be tested, rigorously tested, and perhaps passed in some sense? So there is a huge amount of work here to be done. I think urgent work to be done that is getting done by some of the leading labs, but there's not enough of it. And I actually think we'd be better if independent academic institutes were to do this and join that effort. So perhaps I'll end with, obviously as these systems get incredibly powerful, and probably very, very soon, I think it's an urgent need for us to understand these better. And I mean, there may be other possibilities, for example, like these systems explaining themselves, in addition to us analyzing the representations and things. So I think I've got a lot of optimism that we can do this, but it needs a lot more people, a lot more great researchers joining that effort.